Okay, let's start off some of these problems here with a unit circle. This is a very messy unit circle, but it has all the things in it. I'm going to try and make a nicer one a little bit later, but this is good to start with. And it has all of our, let me just make sure I can clone this here, whoops, so that we can always have an extra copy. I'm starting off with all of my special points. So in blue, I have the pi over 6 points. And actually, this point right here could start as either blue or, well, it's black, right? That's my x-axis, and then my y-axis is also in black. But I'm starting off with my point 0 and 2 pi, and then I divided my half of the circle into pi pieces. I divided that into 6, so I have pi over 6, pi over 3, which is 2 pi over 6, 3 pi over 6, which is pi over 2, 4 pi over 6, which is 2 pi over 3, and 5 pi over 6, which is 5 pi over 6. And I gave each of those points their respective coordinates based on the calculation that I made of turning these into right triangles by dropping a perpendicular. So I know that if I've divided my first half of the circle here, which is 180 degrees, into 6 pieces, pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, that dividing 180 degrees by 6 means each one of these blue slices here is 30 degrees. So I have 30 degrees, 60 degrees, 90 degrees. And then going up from this side, but in a different quadrant, I have 30 degrees, 60 degrees, and 90 degrees. And that same logic goes all the way around the circle. So the first thing I'm going to do is answer the questions for problem number 4, and I'm going to split the screen here and see if we can't take a look at it together. I know it's kind of tiny, but I think you'll do okay. So my first problem here is 5 pi over 6. And I need to change that from radians. I can tell that's radians because it's 5 pi. And that's into degrees. Well, the way to do that by calculating is to multiply by 180 degrees over pi radians. I don't put the radians on there. So if I do that, then I'm going to cancel out my pi. I think what I would do is I would divide 6 into 180, and that would give me 30 degrees. And 5 times 30 degrees, my 5 times 30 degrees is 150 degrees. Well, the other thing I can do is I can look over here on my unit circle, and I can see if I started here and I went all the way around, well, if I go all the way around to this side, it's 180, but I'm only going to 5 pi over 6. So 180 minus this 30-degree wedge is, in fact, our 150 degrees. So that one worked out quite nicely. Let's take a look at our next one. Well, it is negative pi over 4. So remember, when we're working with a unit circle, in fact, any kind of an angle, we always measure an angle. This is our initial side from the origin, the x-axis going out, and our positive angles always open up in a counterclockwise direction, which means our negative angles go in a clockwise direction. Well, I've divided my unit circle up into many different slices, and I know that from this spot right here, going negative to that spot right there is pi, negative pi. Well, if I divided that into 4, it means I've gone to this spot right there, which is negative. I've gone negative pi over 4. So let's change this into degrees. I know it's radians right now because I have pi on the top, so I'm going to change it to degrees. I just take my 180 degrees divided by pi radians. I cancel out my pi. I still have the negative sign though. 4 into 180 is 45. So I have 45 degrees. I still have the negative sign, so negative 45 degrees. Does that match up with what we have over here? Yeah, I'd say so. If I go from here all the way to my negative 90 degrees, that would be negative 90 degrees, but I'm only going to this spot right here, cutting that in half. That is a negative 45 degrees, so it looks just about right. But I'm doing this to try and get you into the habit of visualizing the unit circle when you do these kind of problems. How about negative 210 degrees? Same thing, I'm going to go clockwise instead of counterclockwise. So I want to change this into radians. So I put my pi radians on the top and my 180 degrees on the bottom. Mathematically, what am I going to do? Well, I think what I would try doing is I would first try dividing by 3, see how that works. So this gives me, if I divide by 3, or 30 actually, this gives me 7, and this gives me 6. Oh, I don't think I can reduce it any more than that. So that is negative 7 pi over 6 radians. Does that make sense? I don't know. Let's take a look. So I'm going to start on my unit circle right here, and I'm going to go negative. I think I'll start by going negative 180 degrees, because I know where that is. That's going to take me to right there. And if I want to go to negative 210, I would go another 30 degrees negative. So I'm going to want to end up right here. Well, it says 5 pi over 6, but remember, I'm going negative. So I know that from my 0 starting point, around the outside of the circle, if I go all the way here, I've gone negative pi, which is 6 pi over 6, and I go one more negative pi, that's negative 7 pi over 6, and I'm in the exact same spot. So again, I'm pretty confident in that answer as well. The last one on this quiz here was 450 degrees, a positive 450 degrees. Okay, so I want to change that into radians. So I put my pi on the top and my 180 degrees on the bottom, because remember, those are equal. Pi and 180 degrees are equal 1. So let's do the math here. Oh, again, what am I going to divide by? I think I'll try dividing by 90. That gives me a 2, and this gives me a 5. I can't get any lower than that. So that's 5 pi over 2. Well, let's see. Does that make sense? I'm going to look at my unit circle. I'm going to start here. I'm going to go once all the way around. That's 360 degrees. And if I go another 90 degrees, I've gone 450 degrees, which is what I was looking for. Well, how does that compare to radians? Let's do that in green. If I go all the way around my unit circle, I've gone 2 pi radians, but let's make it in pi over 2s. I've gone 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, and now let's finish it off with 5 pi over 2, and sure enough, it gets me to the exact same spot. So again, I'm pretty happy with my answer there, just by counting slices of my pie.